On this lovely day, we're going to be looking at scale changes of data. So we're going to investigate the effects of scaling data on the display, whatever that means, the measures of center and the measures of spread. I'll look that up, see if that is an accident. All right, by way of warm-up, we just wanted you to experience some inflation because it happens. So 1995 to 2005 in U.S. cities, the average prices went up 25.1%. Prices of medical care rose almost 50%, and rents were up almost 38%. Estimate the 2005 prices of the following items whose 1995 prices were given. So if you have a carton of cereal, so in that case, it's not medical, so it's going to go up 25.1%. So we're going to take and multiply. By the way, when you do multiply, don't multiply by 25%. What do you multiply by? 1.251%. Because the 1, so actually, let me see. Estimate the prices. Since you have to estimate the price, if you only multiplied by the 25% or the 0.251, then that would just give you how much the increase was. So you would have to add that to the 339. So that will give you an approximate value there. Next, rent goes up, and here it says by 37. So you're going to take this and multiply by 1.378. And then hospital room visits, hashtag holy glockenspiel. If you don't have to stay overnight, don't. Oh, we just want to watch you for observation. I'll put a webcam in my house and watch me from there. That'll be cheaper. Actually, buy me 2 iPads, set up a home security system, and that's still cheaper than staying in the friggin' hospital. So that's 46% there.
I'm gonna just get hurt just so I can get those things.
It's not actually going to happen.
I'll be like, no, I'm not staying there.
So after we multiply things out, $4.24, $11.71 for rent, and $14.66 for a bed, and you don't even get to keep it. Welcome back. Now we're going to look at Consumer Price Index. Some of you, at the end of Chapter 2, actually did a small project on CPI. So this will pick us up and talk about it. Now here's what Consumer Price Index is. Inflation is a part of life. So one way to measure how costs increase, the government prices a basket full of common products and services. So they get a basket, they fill it with cereal and bread and coffee and furniture and mortgages. And so what the general costs are, remember, they could charge for services too, like oil changes, right? Common things that we do every day. Not your like upgrading your iPhone to like bling with everything over it, because that's not a common service, right? Okay. And then they compare it over the years. Now, one of them is called the base year. So in this case, the base year is 100. And so it's probably 1967. So based on 1967 prices is where that is. Now, you would just have to know base year is always 100. Not super important information. Just wanted to give you that perspective. So in other words, relative to 1967, prices have increased by 2008, 600. So multiply by 6. That's a massive amount, okay? So as we can see here, within 10 years, so just a little bit more than 10 years, prices got doubled here. Prices tripled really quick by there, etc. from 1967. So let's now take a gander here. Suppose that a refrigerator cost $800, cost is past tense, not costed, in 1995. What might you expect the cost of a similar refrigerator to be in June of 2008? Okay, so notice the two numbers that we have to use. Here is the 2008 CPI, and here is the 1995 CPI. So this is going to give us a nice little proportion. 655.5 all over 456.5. Or excuse me, a little ratio here. But notice that we could actually set this up as a proportion. So notice I put up here the 2008 data on top, And down here, I put the 1995 data on top. So where would the 800 go if I were setting up a fraction here? Should it go in the numerator or denominator?
Denominator.
Well, in my context, it's going to be the denominator. But had you switch things around, then you would just be flexible and switch it around again. So, of course, we're looking for C, the cost. So let's cross multiply. Remember that when you are using a calculator, you multiply diagonally and divide vertically. So just on a calculator, multiply this and divide that in one fell swoop. So we get that C is approximately 1,148, clearly 74 cents. Now that's too approximate. So I probably would round it to 1150 right there. Something like that, because we are doing approximate values anyways. Notice that 800 is a very approximate or a very evenly rounded number, so rounding this one too is probably nice. So what we just did was essentially use this scale to see how the numbers compare between the different time periods. So now it's your turn. Go ahead and attack example 1B. Suppose that an oven cost $450 in 1990. What might you expect a similar oven to cost in 2005? 50. So we set up our proportion like this, and we can essentially cross multiply or simply multiply diagonally and divide vertically. And so C is approximately about $670. Always double check to make sure that things make sense. Notice that the price is not doubling. The CPI is not doubling. From nearly 400 to nearly 600 is not quite a double. So I do not expect this to double up to 900. So roughly a 50% increase that we see there. So what's the scale factor? A scale factor is simply one CPI compared to another. So one CPI or whatever object, whatever thing we're talking about. So here I'm going to call CPI 2 versus CPI 1. So that will be your scale factor. Now you could go backwards as well. Remember, if you have the cost of a refrigerator in a later period and you wanted to compare it for going back, then having the reciprocal down there will actually shrink the price, or so it will seem. Okay, so that would be a scale factor. So let's just take a look at this one right here. Originally, that would be your scale factor. So if I were to just substitute in real quick and then divide, which is 456.5. Now my scale factor here will tell you the growth as a percent. So approximately 1.4, and I'll round to there. So this is your scale factor. However, it also tells you more. This right here tells you your percent growth. Right, in terms of CPI, but if in terms of other things as well. So it's your percent growth. So it's a 44% growth from in that 10-year or from 95. So that 13 years of 44% growth in prices. So what would the scale change in this particular example be? Essentially what happens is every single piece of data, whether it is from one year to the other, so in this case from 95 to 2008, from one year to another, if it were furniture or coffee or whatever, we would expect this to happen, that it would be increased like so. That your scale change would take X and map it to 1.44X, or a 44% increase. So after we enter the data here, we can compute each one of these to be true. Now what's nice, to jump from A to C, you don't have to re-enter data. You don't have to do L2 and scale and all that. All you have to do is multiply everything by 2.5 because it's $2.50 per spam in the place where you live. Ham and pork. Think about nutrition. So all we do is 2.5 times for each one of those. So when we multiply everything by 2.5, these are the numbers that we get. So now let's look at a visual representation. This is the part of the the part of our goal today that said display. In other words, what does the data look like when we do scale things? So box plots of the numbers of candy boxes sold and amounts collected illustrate the effects of scaling on the data values. Also the center, mean and median, and the spread, the range, IQR, standard deviation. And as you saw in the activity example, scale changes not only affect the data, but they affect the measures of center as well. So originally, here is my range from here to here. But now my range is increased, and as you can see, the range itself is more than doubled. And my starting point is right here at, I think the low was 27, and now my starting point is up here in the 60s. Same with my upper, my max and my min. IQR gets stretched out as well. So everything does shift, and so visually that's what happens. It actually expands the data out quite a bit. So that brings us to our two theorems, which you can easily see. Multiplying each element of a data set by a factor A multiplies each mode, mean, and median by a factor of A. Straightforward. This is very, very, very similar to adding H to translate everything. Because adding H does all that. So let's look down here at the summary. Scaled data. When multiplying the data by A, then the mean, median, and mode each multiply by A as well. In comparison to our translation, if I add H to all my data, then I add H to each of my mean, median, and mode. And the last one here, in each element of a data set, if it is multiplied by A being greater than 0, then the variance is A squared times the original variance. The standard deviation is A times the original standard deviation, and the range is A times the original. So, standard deviation, range, and IQR, all of them multiply by A. Now, of course, the caveat in there is that variance is multiplied by A squared.